All right, here we go, Algebra 2. Ready to do ellipses? I think before we start, though, I just kind of want to summarize a little bit of what we've done here. So if you take a look at this, so far you've done circles, parabolas, and you have the two different types of parabolas. This is the ones that open up and down, left and right. And now we're going to do ellipses. And if you notice, all of these equations involve an x squared and a y squared. That's kind of where we're at right now. And we're going to head into hyperbolas, which also involve x squared and a y squared, but we'll look at those next time. So, here we go. Alrighty, so here we have graph and write equations of ellipses. Now, just to get out my little styrofoam cones here, which seem to amaze you guys, if you take a cone, because again we're doing conic sections, obviously, and you slice a plane through it, on an angle, not parallel to anything, what's going to happen is you're going to get what's called an ellipse, which is kind of not really a circle, it's sort of a stretched out circle, kind of like an egg shape. It's going to have a major axis and a minor axis up and down, and we're going to look at finding all the parts of that. So that's what we're doing right now. We're doing an ellipse. All right? Okay. Here's some vocab. Major axis of an ellipse is the longer axis, and you can see that right here. The minor axis is the shorter axis, and I'll show you how to identify that. The center for this section is always going to be at 0, 0. For us, the midpoint of the ellipse is always going to be at 0, 0 for this particular section. And we also have a couple of words called the vertices and the covertices, and I'll show you what those are in just a second. So right now, what I'd like you to do is just take a moment to do the warm-up and pause the video and come back when you're done. So what I recommended here is that you start by dividing everything by 36. And when you do that, you get this fraction 9/36, which reduces to 1 over 4, which I just kind of wrote like this. And then 4 over 36, which reduces to 1 over 9, which I wrote like that, equals 1. And then it begins to look like this up here. And you can see in the denominator is a squared, so you just take the square root of it, and a would be plus or minus 2, and b would be plus or minus 3. And that's how you do that. All right, to start with ellipses, we have to kind of go through some of the standard form things and the components of the standard form. What I want you to remember throughout this whole thing, and it's important to remember this, is that a is always the bigger number. And that's relevant in when we go to figure out where the focus is. So, you can see this equation here. We have x squared over a squared plus y squared over b squared equals 1. With an ellipse, it's always going to equal 1. Okay, the standard form of equation of an ellipse is always going to equal 1. Now let me show you the different parts. All right, if a is underneath the x, which is going to be the bigger number, that tells you that you're going to have a horizontal ellipse. Okay, the longer axis is going to be the x-axis, and your a's are going to be here, a0 and negative a0. And this is going to be a vertex, or one of the vertices, and the vertex. Okay, now b is going to be on the minor axis, the shorter axis. So that's going to be here on the y-axis, which is 0b here, and 0, negative b here. And that is a covertex. Okay? The center is always going to be in the origin for these. And the other component we have is what's called the focus. The focus is going to be two spots the same distance from the center somewhere along the major axis here. So I'm just going to kind of put a spot right here and right here that are sort of this, well, it's supposed to be the same distance apart. Okay? This is the focus. And the focus. Plural is called foci. In a parabola, you remember there was one focus, and it kind of was the parabola rotating around it. Well, it's the same thing here with an ellipse, except we have two focus. It's kind of like the center of gravity almost. It's sort of like the ellipse rotates around the two focus. And I'll show you more about that in class tomorrow. But what I do want you to know right now is if the focus is on the x-axis, it's going to be C0 and negative C0. Okay, so those are kind of the components that you're going to be finding here and where they lie on the ellipse. Here, it's pretty much the same thing, but you can see that A is under Y, and A is the bigger number, which means the vertical axis is going to be longer. Okay, it's going to be a vertical ellipse. So if that's the case, then what happens is my A is going to be here. That's going to be my vertex, wherever A is. Consequently, this is where my B will be. Okay, so that's going to be B0, and that'll be a covertex. And this will be negative B0, and that's also a covertex. Okay, again, we're always having the center at the origin. And now here, the focus always lies on the major axis, the longer axis. So somewhere along here will be a focus. And because the focus is on the y-axis, it's going to be 0C and 0 negative C. So that's kind of how it's laid out. This little handy-dandy equation is sort of derived from the Pythagorean theorem. I can show you that at some point, but this is how you find the focus. C squared equals A squared minus B squared. And you have all those components in the graph here. And that's how you find it. Ready? Okay, so let's practice a little bit. So it says graph the equation, identify the vertices, the covertices, and the foci. This is A, this is B, and this is C, remember. So it's real easy to identify A and B from the equation given. Remember, A squared is always under the longer axis. So since 16 is bigger than 9, I know that it's going to be a horizontal ellipse, and A is going to be positive and negative 4. B is going to be plus or minus 3 when I take the square root. So again, since this is under x, 4 and negative 4 is going to go on my x-axis. So here's a vertex and here's a vertex. And automatically I'm going to write here vertices are plus or minus 4, 0. Those are my two vertices. So here and here. Okay? Now I can also write the covertices. Since it's plus or minus 3 on the y-axis, I'm just going to plot that there and here. Remember, this would be 0, positive 3, and 0, negative 3. So it's going to be 0 plus or minus 3 for the covertices. Now I can kind of sketch my ellipse. It's kind of like an egg, sort of. And the last thing I need are the foci. So remember, I said you can use this equation to get the foci. C squared equals A squared minus B squared. So C squared equals A. It doesn't matter if you use a positive or negative version, because when you square them, it gives you the same number. So A squared is 16, B squared is 9, C squared is equal to 7, which is equal to, then C is equal to plus or minus the square root of 7, which is approximately 2.65 plus or minus. So I can write right here, and since x is the longer axis, the focus goes on the longer axis, so it's about right here, 2.650, and about here, negative 2.650. So it'd be plus or minus 2.650 for my focus. And you've done it. Isn't that cool? Doing such big boy math now. All right, let's try another one. Now, first of all, I noticed that this is not in standard form, so I can't really do anything with it until I put it in standard form. And that's kind of why I had to do that warm-up. So notice that we need this to be 1, so we got to divide everything by 100. So divide everything by 100, and you'll end up with this, x squared over 4 plus y squared over 25 equals 1. All right, now notice that this is the bigger number, so this is going to be my A, which is also going to tell me that I'm going to have a vertical ellipse. I'm going to have a vertical ellipse here. Okay, so I'm going to start with that. A is equal to plus or minus 5 if I take the square root of that, and B is equal to plus or minus 2. And this is on the x, no, excuse me, this is on the y-axis, and this is on the x-axis, because it's underneath the y. Okay, so I'm going to go ahead and graph that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is my vertex and vertex. And then I can do negative 2 is my co-vertex, and positive 2 is my other co-vertex. And then I can just sketch it. It's kind of a skinny egg there. All right? Pretty cool. So now let me just label these points just so you know where we're at here. All right, the last thing I need are the foci. They're also going to lie on the major axis, the longer axis. So I do that by doing c squared equals a squared minus b squared. C squared equals a squared, or a is 5, squared is 25, b is 2, squared is 4, so c squared equals 21. And I need to take the square root of both sides, so c is equal to plus or minus the square root of 21, which is approximately 4.58, plus or minus. Okay? So I can go ahead and graph those. 1, 2, 3, 4, and it's really quite close to both of my vertices. So that is 0, 4.58, and 0, negative 4.58. Okay, so those are the two types of problems you're going to see at first. And then you're going to be asked to write an equation of ellipse that has the given vertex and co-vertex with the center at 0, 0. The first thing you need to notice is that the vertex has the y value, and that's bigger than the co-vertex. So that means that this is going to be a vertical ellipse, and you're going to use this, because A is the bigger number. So let's fill in what we know. We know that we have x squared over b squared. This must be A, and this must be B. Okay, so b squared is 16. Y squared is going to be over 49, and that equals 1. And you're done. Same thing here. X is the bigger number. So that's going to be my A, and this is my B. And you're going to set it up as this is your A, so you got to square it. That's 49 plus y squared over 4 equals 1. And you're done. Easy peasy. Okay, turn the page. All right, here is kind of an application problem. Marketing research shows that a hand lotion bottle with an elliptical base is easier to hold than a similar sized bottle with a circular base. Write an equation of the ellipse and find the area of the elliptical base. So let's look at this first of all. Remember, A is always the bigger number. So this is A here, and this is B here. Okay? So A is like the distance here from the center to the end, which is 4. We would write this point here as 4, 0. So we know that this distance is 4. Okay? So A is 4 and B is 3. So I'm going to write the A underneath the x squared. Okay, because it's a horizontal ellipse and the x-axis is longer. So then 4 squared is 16. 3 squared is 9. There's the equation of the ellipse. It's a pretty nifty drawing, isn't it? I freehanded that. Okay, so then the next thing it says was, all right, so I had to do that. I did that. And then I also had to find the area of the elliptical base. And they tell me to use this equation. All right, well, area equals pi times A, which is 4, times B, which is 3. And I could write that like this. Either I could write area equals 12 pi centimeters squared, or I could multiply it out and say the area equals 37.7 centimeters squared. All right. The last type of problem you have to do is write an equation of the ellipse that has the given vertex and focus. Okay. So here is the vertex. And we don't know if it's bigger or not. Okay, I'm overriding what I just said. Obviously, they're telling us it's the vertex. The vertex is always on the major axis, the longer axis. So this is my A. Okay, and it's going to be a vertical one because it's the y coordinate, but we don't really need to know that. And then my focus, they're giving me the focus this time. Now remember, from my picture in the front, the focus is C. So in order to write the equation, I have A and C, I need B. So if you go back and look at the front page here, well, this equation doesn't have C in it. This equation doesn't have C in it, but this does. I have C and A, and I can find B. So I'm going to use this equation to help me write this. I need to find B. So C squared equals A squared minus B squared. And C is 8. A is 10 minus B squared. 64 equals 100 minus B squared. Subtract 100 from both sides, and I get negative 36 equals negative B squared. Divide by negative 1, I get B squared equals 36. Then B is plus or minus 6. Okay, so to write the ellipse, I now have A and B. And since A is in the Y position here, that's going to go underneath the Y. And this is my B, 36 equals 1. And you are done.